Optimization of a strategy for cycling. Our project focuses on the identification of a muscle fatigue index from a SEMG during a cycling exercise on a trike. While cycling, there was a resistance applied to the pedals, which increased of 5% every 90 seconds. We also acquired 4 signals from sensorized pedals. After the pre-processing phase, we divide the entire signal into 90 seconds intervals related to the level of resistance applied. The starting and ending point of each cycles were known thanks to the presence of an encoder. For each interval, we removed the first and the last 10 cycles to obtain a clean signal. Inside each interval, we selected the 30 cycles of frequency closer to the average cadence of the exercise. Selecting this way, cycles are not consecutive, but this is not a problem because we treat each cycle as a single signal.
To detect muscle fatigue, we implemented the normalized limiter of spectral fatigue index, which is obtained as the ratio between spectral moments of orders -1 and 5. These were obtained from the power spectrum computed with the Westminster for its cycle between 25 and 450 Hz. From literature, we have discovered that our index must increase with muscle fatigue, and we obtained the correct result, as shown in the example. We compared our index with the medium frequency index, which is largely used for isometric exercises. The medium frequency should decrease with muscle fatigue, but it is not very reliable because it can be affected by the increasing of the resistance applied to the pedals and by the heating of the muscles during the exercise. Conversely, our index is reliable, as from literature we have read that two conditions must be proved to be sure the index is related only to muscle fatigue. The overall amplitude of the EMG increases throughout the exercise and its medium frequency decreases, as shown in these two graphs.
Analyzing the trend of the index for each muscle of each subject, we can notice that the index follows an increasing trend within time for all the muscles in almost all the subjects, particularly after the fourth interval. The most significant plots are the ones related to the rectus femoris, as the hamstrings are less involved in the exercise. We proved it by studying the forces exerted by these muscles on the pedals over time. They remain almost constant during the whole task. Generally, the index has the clearest trend for the right rectus femoris because it is the dominant leg for each subject. We could validate our index by proving it's really dependent on muscle fatigue and not affected by the increasing of the resistance applied to the pedals with a protocol based on exerting constant power instead of constant cadence. We also thought of a protocol to be used in real-time applications. We can consider the first minute of exercise, calculate the index, and fix this to 0. Therefore, for each consecutive cycle, we can see if the index is correctly increasing, leading to muscle fatigue. If we also wanted to highlight a threshold representing when muscle fatigue occurs, we would need a previous calibration on several subjects to find a value of the index which can be considered as the onset of fatigue on the majority of people, both healthy and injured. Thank you.